All right, well, welcome to the Coding with Callie meetup, Morgan. Go ahead and introduce yourself and get started.
That sounds good. Hi, I'm Morgan Bridges, and I am here to talk to you today about serverless cloud SQL. It's been kind of like a dream. It's have your flake and need it too. And when I say flake, I mean like, data flakes. It's a dad joke. But yeah, so who am I? Why do you care what I have to say? Well, these probably won't give you any reasons, but yeah, I've been a software engineer for about the last 10 years. I'm currently a senior site reliability engineer too at HashiCorp on the observability team with Callie. I was a senior staff software engineer at a business intelligence company called NewtonX for a couple of years, helped them rebuild sort of like a batch processing system to a mass communication streaming platform that was super efficient. And then before that, I was a staff software engineer at Samsung Smart Things, working on the cloud platform there for over 80 million cloud customers by the time I left. So I live in Minnesota with my wife, my 13-year-old stepson, and my two puppies, one of which is here. This is Zeus. He is the baby of the family. I'm into playing guitar, Dungeons and Dragons, camping, and home computing. So that's who I am. Pretty cool, if you ask me. But yeah, so I'm here to talk a little bit about distributed systems and within the context of distributed systems, specifically distributed cloud SQL databases. Why do we care about distributed systems so much now? Yeah, global economics run on distributed systems. We have multi-region failover, multiple cloud providers, Google, Azure, across the globe. Need to be federated systems that communicate across all these massive platforms. And you need smarts to do that. Organizational scale, some of them are just completely ubiquitous now. So the size of the data that we're pushing around is completely unparalleled and growing all the time. There's lots of companies that have vertical integration and need to be able to seamlessly operate every part of their business, supply chains, and everything that requires a lot of computing power. And our ability to compute has just been growing and growing. More cloud infrastructure, more high-speed fiber internet, and our data is growing all the time too. And that's what it looks like on a good day. Yeah, so I'm going to talk through a couple milestones in cloud compute. First of all, to kind of give us a picture of how we got to where we are right now. We started in 2006, so 8 years ago, or 18 years ago now. Yeah, I'm old. And that was just with S3 storage, object storage, and EC2, which are essentially the virtual machines that Amazon runs. Those two components will actually be really critical to how we think about cloud compute with Neon serverless Postgres. So bring those up. Google Cloud Platform burst on the scene a couple of years after. Didn't want to lose out on the cloud provider wars. RDS came around. So hosted databases. This was revolutionary. Database operations. Usually you had an entire team to run your databases in early cloud and early on-prem servers. So being able to have a managed database service was revolutionary. Azure came to make our third big cloud provider in 2010. And they were definitely competing for all of those Windows shops because lots of business was run on Windows servers for a long time, and Microsoft wanted to get in the game. Yeah, DynamoDB came out in 2012, an entirely different paradigm. Sort of the DynamoDB paper was also the source of Cassandra, document storage databases that are going to be not as flexible in their query access patterns as a relational database, but able to do massive scale and distributed. So we didn't have all of our files sitting on a single disk anymore, and we're able to scale horizontally infinitely. Kinesis came out for data streaming in 2013. And this allowed, this was something that Amazon and still does use internally for almost everything. But this enabled them to start building platforms out like Lambda and then Aurora, which is actually something that was incredibly huge. And then DynamoDB global tables for global in 2017. So yeah, I'll stop really quick for any questions, sort of like on the broad history of kind of how we evolve some of these technologies or what any of these milestones mean.
I think
Cool,
my
cool. Yeah,
question, sorry, would be for like the varying kind of levels in here, how would you like start learning about cloud compute and distributed systems without getting overwhelmed? Like where would you start?
yeah, that's a really good question. So I know that y'all have done a number of projects where you work on things like Kubernetes for orchestration. I think that's a really great way to start thinking about distributed systems because you have sort of a manageable manifest that you're working with. Docker Compose is another really good way, and we're actually going to be looking at some Docker Compose here today, to think about distributed systems. All a distributed system really is a number of computers that are working together for a shared goal, but that goal is being broken up into pieces of work that can be done more efficiently apart. So like that's really all it is. And we take these fundamental components and we build incredibly complex ecosystems out of them. But fundamentally, the same reasoning is applying, and we'll talk about this with auto scaling, at every level of abstraction. So even your own Docker Compose file can be a master class on distributed systems if you're really working with it.
Very cool.
Yeah, totally. So yeah, Aurora. So Aurora was very special when it came to databases. It provided essentially an API for the two most popular databases at the time, Postgres and MySQL. And behind the scenes, you don't have to worry about managing like the storage layer as much. You don't have to worry about a lot of it. It's usage based. You do provision database instances with it. But it also had like a really advanced replication log that was used that was a little different than like the traditional Postgres replication log, and allowed for a lot easier elastic scaling. So you could add read replicas, as many as you want. We used to run databases when I worked at Smart Things that would have 10 or 12 read replicas. If you were to do that with a traditional Postgres database, that has a certain number of replication slots, and the write-ahead log needs to be written to synchronously in order to like, guarantee transactionality. So like Aurora completely changed the game. Aurora now offers serverless stuff, which we're going to get into, and that you don't even have to provision databases for. So the things that we're missing from Aurora are the things that's missing from pretty much every traditional SQL ACID database, which is parallel writing nodes. With Aurora, the way that it was before in the last 6 months, you would only have a single server that could write to the database, and then it would replicate out to a bunch of reader nodes, and all the people could go and traffic those reader nodes, and then you just have to keep the writer from getting overwhelmed. And then, yeah, like the compute is not fully elastic. So what elastic compute means is I can scale up as much as I need. I can scale down as much as I need. So they have horizontal auto scaling and vertical auto scaling for relational databases in AWS now. But what they don't have is you can't scale you can't scale down to nothing when you don't have traffic, really. The engine's kind of always running. And this is something that people who, if you use your database 24 hours a day at a steady rate, that's great. That billing model really works for you. If you don't use your database at all for a week, and then you need to process 10 million records, all of a sudden you need to add all these extra resources, and you're already paying for the database when you weren't using it. And that doesn't really work out for you. So for people with those kinds of just pure burst workloads, serverless, it revolutionized the way that we think about like API work with like Lambda functions. So this is the same thing, but with databases, basically. So we can see that architecture I talked about here for Amazon Aurora, where we have the primary here on the left, and then it's replicating out across this shared log. And then in these other availability zones, we're going to be reading off the read replicas. And this was really awesome and worked well. But
So did you just
yeah,
add space to your database, the primary instance, to make it bigger? Because since you can only ever have one?
Right. So yeah, exactly. So yeah, this provides a really interesting question about auto scaling. So, you would be thinking, right? So I have 10 reader nodes and they all take, and then I have one write node. And
Yeah.
say my reads and my writes are the same number. So I would need a 10 times larger writer node to equal all the reader nodes. So maybe I want my writer to be bigger than the readers. And that, when I first started working on these kinds of database clusters, I was like, yeah, that seems like an easy solution to the problem. Well, that
Yeah.
is until you need to fail over to a different one of your read replicas because something happened in the availability node, zone of your write node, and all of a sudden you're sitting on 1/10 of the hardware. So really trying to like architect a system that works that way um, is really complicated, and it's kind of brittle because it's state based. When you're counting on different nodes in the same cluster to have different states, that's not an operational model that's like super viable for
Right.
me because mistakes happen. That's a really, really fantastic question, though, Callie. Any other questions or comments anybody has?
I've never asked a question that Morgan said no to, so feel free.
That's true. Cool. Yeah. So workload elasticity. This is really what it's all about. The ability to do as much work as we need to, no more, no less. And there are different levels of this, kind of like we were talking about with the Docker containers. So like our first level is application scaling. So I've done this with Python before. It's really popular to have sort of like a worker pool model. And then I would have, like your main process. So I might have a Flask app in Python or a Django app that has a web API with some number of Python processes handling the requests, and then they're delegating out to 3 worker pools to get the work done. And if it's asynchronous work, that work can just be like delivered to the output. So we could use the same number of CPUs, but run more or less process on those CPUs. So we're doing a type of scaling there, right? We're saturating our provisioned CPU. So we've got another type of scaling, right? So this would be like your Kubernetes horizontal pod autoscaler, or if you've got an autoscaling group of EC2 instances in AWS. This is where we actually change the number of units of compute that we're provisioning from the cloud provider. So instead of saying I need more Python workers, my CPU is full. I need more CPUs. That means I, keep adding pods until I have enough capacity. And then so this is, sort of like I'm scaling up my cluster. Next level of scaling, multi-cluster federation. So we work for HashiCorp. This is HashiCorp Nomad, and this displays Nomad's ability to have multi-cluster federation across different cloud providers. We have like our Google, our AWS, our Azure here, and also different regions. So really, with this kind of multi-cluster federation, you can create a network that spans the entire globe, every type of compute resource, and there really is no such thing as downtime if you did this perfectly,
How do
which
you not
yeah,
way over provision this though?
yeah, great question. So yeah, more or less the answer is cellular architecture. When you have something that's this scaled, each individual component needs to be able to operate on its own, do its own scheduling. And that's usually how this goes, is that inside each one of these clusters, there will be a single pool of servers that will be doing the scheduling component, but we have information that's flowing across gossip so that we know about kind of the states and up
Okay.
and down and service discovery from our other clusters. So we're sharing context and information, but we're not necessarily making decisions together. Sort of like how your manager works with you and the other developers on your team. And and another manager is doing the same for their team, but they don't necessarily need to be able to give each other's teams work, but they are talking and get together in meetings and stuff, right?
Would it just
Um,
scale down like I'm gonna say pods because
yeah,
Kubernetes, but okay, so like would it just scale down the pods in each
yes,
individual cluster, or would
right.
clusters go away too if they weren't necessary anymore?
So it really depends on the architecture, of
Okay.
course, because it's always the answer is it depends in
Yep,
computer
yep, yep.
in yeah, this kind of architecture. But what I would say is each individual like sort of like command cluster will scale based on the work that it needs to do. With
Okay.
these type of like geographical layouts, usually there are people, users who are local to that area, and their workloads will determine what actually runs on their cluster. So it'll depend on like whoever's in the region doing that work. And this is just a theoretical application, but that's basically what I would say. Hey, Johnny, question.
Hey Morgan. Yeah, I'm looking at your picture here, and I guess it's just like a question. I mean, is this how like edge computing is sort of like set up? Like for example,
Yeah.
I'm pretty unknowledgeable about what I'm talking about right now. So if I use terms that don't really specify to what's going on here, that's why.
No, you're exactly right.
But
You're
yeah, like,
exactly right. Yep.
for example, like there's some services where, for example, Torso, for example, like it offers servers that are close to the client.
Mm-hmm.
And I'm just curious because I see this like it's mapped up across the entire world. It looks like that's how it's also set up, where it's like close to the
Yes.
yeah.
Yeah. So just like you want to use an NVMe drive instead of a SATA drive on your gaming computer, you want to have your command structure close to the work that you're doing, right? So yeah, the best way to design this is to have geographical co-location between the actors who want to do stuff and the computers that are doing it. And there may be some sort of like federated sharing of information, but yes, you're absolutely right. And edge computing is the same concept. So like when we worked at Smart Things, we wanted to push a lot of processing onto the hub so that when people emit commands to their devices or they get state updates, that actually we don't even need to go to the cloud. We'll just tell them what we did. And it's the same concept, right? You want to do the computing where it needs to get done. Make sense?
Got it. Yeah, it makes sense. Thank you.
All right, this guy knows a little bit about edge computing. What's up, Jeff?
Where would you define geographic computing versus edge computing versus like in-home and cloud? Where are those lines?
Oh, I like this question.
Yeah, honestly, I don't. That's a really good question. I guess I would consider edge computing to be sort of pushed down to layers of abstraction that are closer to the client. I guess is sort of how I would define that. And that can mean different things in different contexts. Geographical computing, I mean, that's going to be mostly like region based, and that is different, right? Because I have all my server infrastructure in US East 1, I have all my server structure in AP Northeast 1, and it's the same structure, but people just talk to it different ways depending on latency based load balance, whatever. That's not the same as edge computing. That's a good thing to say. And then what was the last one? There's edge, geographical, and what was the last one?
In-house and cloud.
Oh, in home. Yeah, I mean, in home is just further into the edge.
I lost my mute button. Sorry.
Oh.
I was just it's a
What do you-
spectrum, and I don't know how you where you draw
Yeah.
the lines. And if it sounds like you're saying it depends on the use case.
Yeah, I'm no expert, by the way, in the topic of edge computing. But yeah, I guess when I think about it, it's like, well, what's the opposite of the edge? And I guess it would be the center. So if the computing is happening somewhere other than, I mean, part of what edge computing is to not have everything be like congested onto these centralized massive servers and everything has to go through it. It's a single point of failure. So I think edge computing is really sort of a step towards the desire for computing to be truly distributed. And that processing can happen somewhere other than like the mother brain or whatever. But I don't know. If somebody has a better definition, I'd love to hear it, because I definitely did not come here to talk about edge computing. Anybody else have thoughts?
So is edge computing is very similar to CDNs, caching?
Right. Yes. Right. Yeah, I think that makes sense.
Okay.
Yeah, and that's a great point. We use tons of CDNs at work today, because I mean, one of the main things people do for HashiCorp is download the AWS provider, which ain't no small bundle. It's pretty big, and people download it more than it's one of the most downloaded artifacts in the world. I bet it's up there anyway. Yeah, sweet, great commentary and topics, everyone. And then this is just my yay. I got to use HashiCorp for an example. There
Oh,
you
it
go.
faded out too. That was nice.
Yeah,
That's very cool logo.
yeah, it is. It is nice, isn't it? Yeah, it is. I really like it.
Yeah.
Cool. So I'm going to do a little demonstration of Neon. So Neon is serverless Postgres. It basically takes all the concepts we've been talking about, sort of like S3. It uses object storage with the S3 API. I'm going to show you a version of the S3 API called MinIO that I'm running locally that provides the same API. And show you kind of how that works. So we basically swapping out our disk drive that would be in a Postgres server with object storage, which can be distributed and will be for this. So it's open source. So I never got to look at any code for Aurora, and I can look at code for this. It's written in Rust too, so I want to learn Rust. That's why I chose it to look at. It's got distributed / partition storage. So we're partitioning it by organizations, by tenants. So Neon is multi-tenanted by nature, which makes it really nice if you're like a service provider company, because you're automatically where the files go for your logical database. And when I say logical database, I mean it's like the database that is owned by company X. Like there are no physical databases in Neon. There are logical databases, and they get distributed across all these S3 buckets, depending on which thing they're for. The read is incredibly scalable. So because the compute, and the storage are completely decoupled in this, it's basically just like Lambda. You can run as many compute workers as you want, and those will be sort of like the Postgres interface that you get. And then there's a page server on the back end that is actually doing the translation between the relational database language and the object storage backend that they use. And then, yeah, scalable write too, because we're partitioning out our object storage, and it's not related to like a database server. That makes it a lot more scalable. So there's a write ahead log for this too, similar to Postgres, where every transaction that you have gets written first to the log, and then it gets committed to like your in-memory page caches. The write ahead log for Neon is actually point-in-time recovery for any commit, because it's got a constant, it's constantly able to reconstruct the entire database, which you can also branch the database. So if you have your prod, say you're in a startup, you get to production, and now you're like, dang, I need a dev environment because I'm pushing too many bugs to prod. You can actually branch your production database into
amazing.
a dev database. And then you can say, oh, here's our dev database, because of like the branching features that it has. And then, yeah, on-demand compute, just like Callie was talking about, you want to be able to scale down as well as up. You only are executing the queries that you actually need to, and there's no infrastructure just like sitting around running.
Is there like a break-even point in terms of like when you would, because I'm assuming like cost by query could potentially be more than the storage.
Definitely.
How large would it be before that's true?
Yeah, I wouldn't even say that it's a scale thing. I would say it's more of like an access pattern thing. If you have, like I was saying, 24 hours a day, you're running a consistent number of queries, you know about how much growth you're going to have over the next X amount of days, months, or years, it might not make sense to do something like this. If you're really early and you expect that you might have explosive growth, you have super bursty access patterns of reads and writes, it might make a lot more sense. But yeah, it's not like you get to some certain scale and then Neon works better for you. Unfortunately, life's never that simple, especially with this kind of stuff. Yeah, Manuel, great to see you, dude. What's up?
Yeah, same here. So you got me with the database branching. That sounds very interesting. I think I have seen this so often where you want to just like, oh, we need something similar to production because environments are so different that it just breaks.
Every company I've worked at has had this
Oh, yeah, same here. So how do you handle private data? Because I want to branch out production, but I have PII information there that I don't want on staging.
That's a great question. Yeah, I didn't see anything. In it. That doesn't mean shit though, because I barely looked at this. So I mean, like I've been looking at it for a couple weeks for fun, but I honestly don't know is the answer. But yeah, you would definitely want to do some kind of processing for that. anonymizing the data. I know tools exist for it, but I don't know if there's something built in here. It's a great question though. Thanks, sir. Yeah, so I'm gonna breeze over this quick. I want to get to the demo.
You do have a question in the chat, by the way. It just came in.
Okay, cool. One moment. I don't have it open.
Oh, sorry.
No,
No,
it's
it's
all good.
you.
It's all good. I got it. How does Neon handle backups? Like backing up the data in case something happens in a storm? Good question. Neon keeps a consistent write-ahead replication log that gets written to before we even tell the client that the transaction has been successful. And that log can recreate the entire database from any point in time that you want. So you have continuous backups, which is something that actually point in time recovery costs quite a bit if you take snapshots that quickly on traditional databases. So it really is a differentiating feature for Neon, is that that's all going to be on the volume where your object storage is. But, you know, then you have to make sure that that volume where your object storage is like a backed up consistent volume as well, probably, is the true answer to that. Or you could use S3 and just trust me, bro, to Amazon. Although Amazon actually does have really nice bucket versioning now. I've noticed that feature got upgraded recently. I'm going to breeze through this. Yeah, I hope that answers. Does that answer your question, Nisha? Yes. All right. So I'm going to breeze through this quick. Basically, the differences in the architecture. So you can see that for this Postgres server, and this isn't like Aurora, this is Postgres, we basically have one big server, and it's going to do everything. It takes the request from the client. It's going to run the engine. It's going to commit to a shared buffer. There's going to be a wall writer that's going to drink the buffer and write it out for wall files. And then you also have your writer for data files. So that's another thing about the way Postgres does it. You've got this massive shared memory buffer, then you've got your wall writer and your data writer. So you got two huge files, and that wall file can get really big, and it can be kind of complicated to configure the wall to really work the way you want it to in traditional Postgres. So yeah, basically the way that Postgres is really fast is it uses the shared buffer really efficiently, puts the dirty pages there, and then reads from them before committing through, as long as the write-ahead log has been written. Yeah, cool. And then Neon is a little bit different. So Neon, we got our computes over here. So instead of one big server where all of the data access is happening, the caching is happening, we've got our compute nodes. And our compute nodes are running the queries, and they're caching results. And there's a lot of sophisticated caching in Neon where it can do things like notice which pages are hot and make sure that those are always cached more frequently. It can avoid doing writes if it can see that it doesn't need to do one. Like I was doing update statements earlier and looking at the logs and noticing that I wasn't always seeing them because of some of the caching. So basically, those are our actual like Postgres servers. We can scale this compute as much as we want, up and down. And then in the back, we'll have page servers, and those page servers are going to be responsible. Each one is responsible for some subset of the partitions. And then that's going to have multiple safekeeper nodes, 3 of them that are going to be in quorum. And they have a consensus algorithm that's based on Paxos that they're running to make sure that that they agree on what the write-ahead log looks like. So that goes to object storage, and page server also goes to object storage. So we have the same sort of like data file and write-ahead log thing happening, except that we've split it up into 3 services now that can all be scaled independently, which is really fantastic. Cool. So I think I covered what Neon does differently. I'll share the slides. And then I have a resources slide on here too that is part of the repository that I'm going to share, so you can see it there. But yeah, so I'm going to show you a little bit about what I'm running here for Neon. So right now I am running a Docker Compose file that Neon provides that's going to start a number of services. So for those of you who don't know, Docker Compose is just a way of running multiple Docker containers orchestrated together and then networked together. They're all going to be, I think these are all just default networked, but yeah, they're going to be essentially together in a network, and now they can address each other by local DNS. Go ahead, Ashwin.
Hey, sorry, Morgan. So the previous slide that you were sharing, you said some object storage. So in traditional databases, at least as far as my knowledge goes, it's very hard to save binary files like videos or images, right? We usually put that in the object stores. So with Neon, I can just save those files as well, or does it give me any performance improvement?
Yeah, I mean, it's going to operate, it's basically bytes over the wire. So I think it's going to be equivalent. Although I will say that Postgres blob storage has gotten a lot better in the last couple of versions. So I know that there are companies that are using Postgres for like massive binary files. But yes, that is a really good question. All right, Graham, go ahead.
Hey, real fast. So I just learned about Docker, trying to wrap my mind around it. When you deploy it, do every one of these little containers that like your 10,000 user base are going to be talking to these little containers? Is that appropriate, or am I way off base in my understanding here?
Yeah, if I were going to do a production deployment, I wouldn't do it this way. So what I've got here is essentially a demo that I'm showing. And when I was talking before about how you can learn distributed systems through Docker Compose, not necessarily saying like you can learn how to scale a massive cloud ecosystem with Docker Compose. I'm talking about learning how to do the fundamentals of networking multiple pieces of software together, building up like, API contracts between them. Like you can design the architecture there. And then when you build that out, you're going to have like a more sophisticated CI/CD pipeline and probably either an orchestrator of some kind, whether it's Kubernetes, whether it's Nomad, or whether it's like AWS Code Deploy and CloudFormation and that kind of stuff. So there's lots of tools to do infrastructure automation. HashiCorp has some of them if you want to check them out. But that's kind of the answer, is that Docker Compose design and develop, and then deploy is going to be somewhere else.
Okay, great. Awesome. So much. All right,
yeah, no problem. Great question. Thank you. I think who's next? Was Manuel or Jeff next? I can't tell.
Manuel.
All right, Manuel, go ahead.
Oh, okay. I thought it was left to right. There are hands, but it's okay. Maybe too specific of a question, but is the Paxos a Byzantine Paxos or a generalized Paxos, or what's the level of reliability? I just want to know that for use cases.
The level of reliability for the consensus algorithm for the safekeepers, honestly, I don't know, man. I know it was a Paxos-based algorithm, but there's some benches and stuff. And the Neon repository has benches too. I'm not sure. They do offer a managed cloud version though, and I guarantee they have SLAs on that. So I would check that.
I'll check that. Thank you, Morgan.
No problem. All right, Jeff, go ahead.
Before we get deeper into your demo, I wanted to understand the wall file. I don't know it that well.
Yeah.
Is it like an immutable, like I know Cassandra and Kafka, is it like immutable SS tables kind of like those, or is it something else?
Yeah, that's basically what it is. It's
okay.
Yeah, it's an immutable transaction log of everything that occurred, states and
great
commits. Yeah, cool.
Makes sense.
Yes, absolutely. Manuel, go ahead.
Sorry, I did
got it. Cool.
Lower my hand. I will do
All right.
Morgan, sorry, quick question, kind of on track a little bit, but not really. From the chat, there's confusion about Docker Compose being used for production versus like spinning things up locally. Would you use Docker Compose for production ever?
I think you could. Generally, Docker Compose is going to be used for things where you want to run multiple services on the same host. I think that there are other tools that are more well suited for production use cases. But I mean, there's no reason you can't. So I guess if you want to use Docker Compose to orchestrate services together on like a virtual machine, or I guess my question would be like, where are we running it? You know what I mean? It doesn't necessarily provide like a runtime for that. Whereas if I'm like running a Nomad task, that's going to be provisioned and run on one of my Nomad servers. I need some orchestration too. And then with Kubernetes, you wouldn't really use Docker Compose because you'll just do your orchestration with Kubernetes. So I'm just kind of like, where are we slotting this in? But yeah, I mean, we could design something that used it. Vagrant, Docker Compose on an EC2 or a bare metal back in the basement or whatever we want. Yeah. But production for what? That's the other question, is like, what are we doing? You know what I mean?
Awesome. Thanks, Brian.
Yeah, no problem. Great questions. Really, really fantastic conversation. I'm appreciating it. Cool. So yeah, basic components that we have here. Yeah, so like I was saying before, we're running our min.io. That's our S3 essentially. This is just a service that's going to create the buckets in min.io for our page server to use and our safekeeper to use. And then, yeah, we're running the page server.
And min.io is just a different API tool to communicate with S3?
Yeah, it is a S3 API compatible object storage. So it has the same API as S3. You can just run it locally, or it's portable. You can run it.
Oh, okay. So it's
so you don't
like
need AWS.
S3,
right?
But it's not S3. Okay.
So if I change this out and I put my S3 bucket address or whatever in, it would just work. That's the whole idea. So I can develop against min.io or local stack. Local stack is only really a development tool that AWS provides, but min.io is actually like a fully fledged object storage that I think you could run that in production.
Okay.
Yeah. Great question. Great question. Keep it coming. Then we're going to have our safekeepers. You can see that we have 3 of these, and that's because we want to have the quorum so that we have that consensus algorithm we were talking about running. And that's about it, other than, oh yeah. And then this one is just saying, hey, is my compute ready? We're checking on the compute. And after all this is done, all this stuff is going to run, and then I will have a Postgres endpoint that I can interact with, and I'll show you all how that works. Cool. So yeah, I'm already running this stuff. We can see page server logs. We can see compute logs. I'm going to run over to this notebook that I put together for this. So if we look in our database right now, we can see I've got 2 tables, or I've got a few tables here. This is a health check table that Neon is using. And so that's there. And then I've got PG stat statements that I can view in my views. And this just actually, for people who are interested in Postgres, this is essentially where you can look at any recent queries or transactions that have happened. And you can actually like see the state of them as long as it's not protected, and I have permissions open on this. But this is pretty cool because you can explore the queries that have been made. And there are extensions you can get to make it a lot more detailed too, but I don't have them activated. So we're going to need a database. So let's create a database. I've got so this is, this is a, for those of you who don't know, this is a Python notebook. It's a Jupyter notebook, other way of calling it. So it just provides really easy ways to put like documentation and code next to each other for things that are more like presentations or demos or whatever. I like to use them. And, they provide a nice little isolated runtime, so I can just run little blocks and kind of do my thing. So this is all environment setup up top. I'll skip over that because I did that already, so as not to bore you. But it's there later if anybody does want to play with it. So first thing I'm going to do is I'm going to spin up my connection to Postgres. I've got Postgres. I've got Neon advertising at port 55433. So this is my connection string to talk to the database. We're going to open a connection, set auto commit to true because I just want all my things to happen without me having to commit. And yeah, we're going to create a table called app awesomeness that has a name and an awesome score. So let's create that. Yeah, and we can see in our logs that stuff happened, definitely. Yep, we've got my identity, cloud admin, authenticating to the Postgres database. So this is the compute worker. So you can think of this as sort of like your Lambda function that's running and actually doing the database stuff. It's communicating back after it does its authentication. It's calling back to the page server. You see here, calling the page server, and we're able to actually connect. And it sees that we're calling on behalf of this tenant right here. On shard 0. So it's going to, know the page server knows which object storage backend we're going to route me to. I only have one right now, but it could be 1,000. And then, yeah, we can see here that we we can see Safekeeper here. After we created those new tables, it needed to emit partial remote segments. So we can see here, Safekeeper is chattering. It's saying, okay, I received this. We're doing a partial backup. So it's doing that right ahead that we're talking about where it commits to it. So now if I go back into my data grip, so this is my, view into like pretending it's just Postgres, right? So if I go back into data grip, I should be able to refresh my database and see, oh, sweet, I got a new table, app awesomeness. And my new app is in there and it's got an awesome score of 100. So that is pretty cool if you ask me. Pretty cool.
Pretty high awesome score.
Yeah, absolutely. Absolutely. Yeah, so we've got that created. That's good.
Are you able to see the
like
what's going in the Safekeeper?
Yeah. Good call. So this is the MinIO console.
Okay.
So this is basically just looking at this UI that it exposes on localhost 9001. We can see Neon has a bucket here for object storage. It's kind of small, but it works. So page server has a bucket and Safekeeper has a bucket. We can go into our tenants, timelines, and we can see, we can see that we have these files here. They're not super interesting to look at in this form.
Yeah.
But yeah, this is where it's stored, and you can see here too that we're using e tags for this. So you can basically tell from that object hash, it can say, just looking at the hash, oh, has this actually been updated? Which is something that is done. The clients will send that so they can know, I actually don't need to fetch this thing. I've already got the cache. So if I cache the e tag on the client side, when I call in, I'll say, give me this thing. I'll say, give me this thing. Here's the e tag. And it'll be like, you already got that thing. But yeah, so we support that. So that's where all the object storage stuff is. And yeah, Safekeeper is pretty much the same. We can see I got Safekeeper 1, 2, and 3. So if we were actually running separate Safekeeper nodes, we probably wouldn't have them all putting their files in the same bucket, because that doesn't seem great for reliability. But for a demonstration, it's good to show we've got our 3 Safekeepers here, and each one of them has their own idea of what's going on. And that's why they need to collaborate. Yes. Good question, Callie. Cool. Yeah. So let's try some more advanced SQL.
Are these files that you're looking at here basically like a dump or a representation of what's in the database?
Yeah, there are 2 things. The page server is basically storing, the data file. So this is what the current state of the database is. When something needs to go and read from the database, it'll go to the page server and get that out. Then the Safekeeper is keeping the log of everything that's happened. So you can play that log to get to that current state of the database or roll it back to a different state, but it's going to be easier to look at the data file, which is the current state, than it is to rebuild it from the log. But having the log, if you have a bad day, is going to be the best thing ever, because you can...
The log has like step-by-step all the steps that it takes to create the database?
Yes. And if you were to replay that log from the start, you could, rebuild your database anywhere. Yeah, exactly.
Do you manually replay the log, or is there like an automation thing where it notices it's out of sync and then fixes it?
Yeah, so the Safekeepers are constantly writing to the log based on the consensus that they have. If you wanted to roll your database back, that would be an operation that you would call on the, I don't know if it's a page server or the compute server, but you would call the operation to roll it back, and then it would move essentially the pointer on the log back, and then it would change, it would undo the current state of the database essentially and get back to that state.
Okay. What if I just deleted my database?
If you deleted the current state of your database, I think you could rebuild it from the log.
Okay, but I would have to it wouldn't be like, oh,
I don't think
it got deleted. I need to.
I don't think anything like that automatically happens. Those are all manual operations things.
Okay. But
even the ability to do them is pretty amazing in the world that we all lived in, when we just had a database in prod, but just even before migration scripts. And for those who don't know, migration scripts are essentially just sequential scripts you run on a database to get a database from brand fresh new to the state that we have it in today, and you can run all the migrations and get to that. You know, before that, the prod database was all we had, and we take backups of it. But like basically the whole game is just like try to keep that safe, and like when degradation happens over time, we have to try to fix it. And that's a really scary place to live in compared to what we're talking about today. Yeah, cool. So yeah, we're gonna make another table because we want to do some joins and show that we can do more complex things across different tables. So we're going to create another table called app companies, and this is going to associate our app companies with our awesomeness scores so that we can know which companies have the awesomeness scores.
It's no snack app, but it's pretty cool.
Yeah, no snack app. That's true. Callie's working on a snack app in Gin. Yeah, so we can see here more successful replication, creating a table. And now we're going to create Bonky Corp. So this is going to be, we're going to create a new app, a new score, a company, and we're going to associate all these things. And we can see, yep, that we were able, and then, yeah, last thing we're doing is we're basically just inserting that new record on the table we just created. And we can see that we were able to do it. Yeah, so a couple other features that I want to point out here that make Neon really awesome. It's got a few things around like one problem with a model like Neon is that when you have a shared cache in memory on a database server, and it's operating on that shared cache and writing directly to like a local disk, there's really low latency between those things. If you're talking to S3 for your file storage, that can be a really latent thing that adds milliseconds, not nanoseconds or microseconds. That can add hundreds of milliseconds to like your request time. In order to get around that, there's a few key features that we've introduced in Neon. It's got predictive prefetch. So for those of you who know, when you have complicated queries in Postgres, you can actually specify to do prefetch of other data, which can optimize the amount of time that you're going to spend building up, like materializing the results of your query. So Neon actually has features that do automatic predictive prefetching. So based on previous queries, it'll prefetch data before you even specify it. And then along with it's got another feature called deferred writes, which means that if it thinks that it doesn't need to commit immediately, or if there's a pattern of multiple writes that might be aggregated, it can actually defer and collapse the state of those writes down so that it'll only have to make a single trip over the wire. So like there's lots of strategies like this that we need to think about in a world where distributed computing is the only option, that we can't just run a big fast server anymore. So we have to come up with clever ways to kind of get around the fact that everything is going to be an API call in an environment like this. Yeah, and what made me think of that is that we saw that we are, it's trying to do this. It's trying to do this predictive prefetch, but I'm not running the full storage manager for this because it's a little bit out of scope for like the Docker Compose thing. But yeah, that's what it's trying to do with that log, and that's a feature that it has here. Yeah, so that's basically it for my presentation. Covered a lot of stuff. I did a lot of talking. I guess in closing, I would just say that Postgres Neon is a super exciting way that you can dig into something that is one of the most revolutionary, like Amazon Aurora, one of the most revolutionary things ever to happen to a relational database. And having an open source implementation like this that shows you how it can be done can introduce a whole, it basically can democratize and open up an opportunity for a whole new generation of engineers to like really be ahead of the game and hit the ground running when it comes to understanding these distributed systems that are only getting built in places like AWS, in places like Google, in places like Microsoft. So seeing projects like this out there in the ecosystem just really jazzes me. And that's why I spent, like a month looking at it on my own time. That's it.
Maureen, are you open to questions just about this presentation or
Do it
all
up.
questions about like career?
Anything.
Anything. Okay. Dungeons and Dragons, go.
Yes. I don't have the new player's handbook. It came out like yesterday. I saw people posting pictures. I want it. I did look at the D&D 1 promotional materials and they look pretty sweet. Yes, Nisha.
Hey, I don't know if you covered this. I might have missed it. How does it handle scaling? Like websites?
Yeah, good question. So essentially, I'll go back to the slide actually, because I think this is really good. Yeah. Desktop 3, that's it. Bam. Okay, so yeah, Neon right here, Neon architecture. So the cool thing about Neon is if you look at the left side, the computes, you can think about this as like a pool, an infinite pool of Lambda functions. And each one of those is going to run a little baby version of the Postgres engine in it to figure out the query that you're doing. And you can run as many of those as you want. And it doesn't impact, like you can run more and more of those. And there's not like you're going to exhaust connections to the storage engine because those are also able to scale at whatever rate they need to. So when we compare this to like a traditional database where everything is in a single box, you basically just have to like figure out what the highest you're ever going to need is, provision that, and then when you use more than you were ever going to use, provision that, you know? So that's why this really is scalable, is that the compute can be scaled completely independently. Does that help?
Yes.
Sweet. Manuel, go ahead.
So I don't know if I missed it. I'm wondering. So just to try to explain my train of thought. This is doing similar to partitioning or sharding, right? So
yeah,
the data storage is just like being put in different places.
Right.
My big question is, how is it deciding how to partition or how to shard? Because usually we'll do the definition of the partitioning key on the tables.
Yes.
But here I saw nothing like that. So I wonder what's the criteria for the partitioning.
There's multiple levels. That's the secret. So there are multiple levels of sharding. The primary level of sharding is going to be for the tenant. So depending on what you're going to use for like your tenancy, that can give you, that's like basically the most broad grained way to partition. If you for somebody who's got a bunch of different customers using the same infrastructure, that's what you would do. You make those tenants would be different customers, and then there will be a different page server that's responsible for each one of those customers. You can scale that out as much as you want. And then those page servers can sort of also scale independently. And then the object storage, there's going to be an additional layer of partitioning for where you actually write it on the disk. And that's going to be based probably more on your keys and sort of like page, because like it's storing pages. So we're still talking about data pages the same way that we are in Postgres, because really this is a Postgres storage plugin. So like the way that it's like loading pages is going to be the same. So we're still storing data pages and thinking about it that way, but there's an additional layer in front of that that's tenancy. Does that help?
Yeah, thank you.
Sweet. Yeah. All right, Jeff, go ahead.
So if you're going to deploy this in production, is there a Kubernetes operator? Is it a bunch of Helm charts? Because that makes me sad. Is it customized? Because that's the one true path in Kubernetes. I have an opinion hat on.
Yeah, so I haven't looked at what they do for that prod deploy. I know that they do use Cargo to configure environments for it. And that's a path that they suggest. So it might honestly be something more akin to like setting up a virtual machine. Although I'm not like a Cargo expert either, but that's the path that seems the most paved from the repository that I looked at. I will admit though that I've only really looked at running it locally and running it in their managed service. I haven't gotten around to the question you're asking, but it's a great question. And if I ever went to deploy this in prod, you better believe I'd post in Discord about it and we could talk about it.
I have a question.
Yeah, go ahead.
this is some great knowledge that you are sharing, Morgan. So my question is, do you think someday AI can do all this and steal your job?
Oh yeah. Yeah, you definitely can. Anybody who loves learning, wants to learn, can do any of this stuff. That I believe that if you have interest in learning it and you invest time in learning it, and you care about it, like, I don't know if I've ever seen somebody who had intellectual curiosity and drive. I don't know if I've ever seen anybody like that fail in this industry. And having that drive and that self-determination is something that's a really rare human quality. So by the way you're asking the question, I can tell that you do have it. So yeah, I think if it sounds like you're already doing amazing things from what I heard when you were coming in here. So I'm 100%. I'm 100% confident that yeah. I mean, this stuff is all just reading docs basically, and then it builds on each other. So like I had to read a bunch of docs. I didn't really know too much about Postgres before 2 years ago because I was running mostly MySQL and SQL Server, and then I worked with Manuel at Newton-X, and I had to read a bunch of Postgres documentation, and that was only 2.5 years ago.
All right,
Ashwin,
cool, thank you.
Yeah, no problem. Thank you. Ashwin, go ahead.
Hey, Marvin. So did you do any performance testing on it? Do we have some metrics against Postgres? Like what's the throughput compared to Postgres, or latency compared to Postgres?
Yeah, check out the I put some benches and some articles in the resources, and I'll share a link to that. It's in GitHub. I'll share a link to it. But yeah, I have that information on there.
Okay, thank you.
Yeah, no problem. Good question. Always a good question to be like, okay, but what does it actually do? I've heard the sales pitch. What's the story? Go ahead, Jeff.
So does it, I'm just rapid firing because there wasn't other ones. ARM RISC architectures, is those supported? Is it all x86?
That's a good question. You know what? I don't
assume
know.
You can tell me to go read the docs, and that is okay. An okay answer.
I have the repo pulled down, and honestly, so I would, God, if it's not, so this is written in Rust, and it's pretty modern, like from what I've seen. I would be shocked if there's not a compile target for it, and I have it pulled down. I will look for it. It's right here, so I will look for that once we're off the call, and I'll Discord it to you. Or I'll post it in the Coding with Callie Slack, and I'll invite you to it, actually.
That would be awesome, because now I want to go see running it on my Kubernetes cluster of
Dude, definitely.
Well,
and you should come talk here.
The next presentation.
Jeff's the vice president of engineering at AT&T, Callie. He's a big deal, even though he's being so.
You're not supposed to say things like that on recordings.
Oh shit.
No, it's fine.
He's a big
just
tech
messing
guy.
with you. It's fine.
He's a big.
He's probably online somewhere. But yeah, you do try it out. Keep us updated.
Yep, absolutely.
All right, maybe one more question. Anybody want to do it?
Can you play on the drums for us?
Sorry?
Your drums.
Can you play on the drums?
Oh, play the drums. My wife is, what time is it? 8 o'clock. And it's a little late. My wife's chilling with the dogs. They're gonna start barking and stuff. It's honestly, it's kind of a special occasion when I get to play the drums these days. Because everybody thinks they're loud.
You look very cool though in all of the meetings.
Thanks. I do play my guitars all the time, and they're not in the frame anymore because they're all out in my lounge, because I've been playing them and then leaving them on the couch, which is another annoying trait I have.
Just a request, Callie. Can you end the recording? I got something to share.
Oh boy.
All right.
Thanks.